Okay, last thing we're going to add today is the phase shift and then just review for our quiz tomorrow. Phase shift is Trig's way of saying horizontal shift, as I talked about before. Okay, we already worked on finding these. We just didn't graph them yet. So when we found the phase shift for a problem like 5 or 3 or 4, all of them had it. What we do is we take C and divide it by B. Okay, so I took the pi, divided it by the b value of 2 right here to get that. And then just like horizontal shifts in the past, if you subtract it, it moves it to the right. All right, kind of just changes our starting point. Like vertical shifts, we change our midline. This is going to kind of change our y-axis, if you will. I'll call it like a pretend y-axis. All right, so let's start with this problem right here because this has a phase shift. I'll walk you through this one and see if you can try it right after it. Again, it says just one period. We're going to do 2 periods. We have been. Determine the amplitude, period, vertical shift, and phase shift of this function. So here we go. It has an amplitude of absolute value of 4, which is 4. It has a period that's equal to 2 pi over b, and b is 1. So this remains 2 pi. So we'll have our familiar tick marks again. Our scale will be period divided by, we basically do quarter periods every time. So we divide by 4 and we get pi over 2. So that's how much this is increasing by. Okay, 3 pi over 2 and 2 pi. Okay. All right, the directions also say to give the vertical shift. There is none, but there is a phase shift. So let's talk about that. Our phase shift is always C over B. Okay, so that's going to be equal to pi over 2, right, divided by 1. To remind yourself to do it, if you actually want to put over 1, go ahead, but we're just going to get pi over 2. And when we add it, it's going to go left. So my phase shift is pi over 2 to the left. Okay. All right, so this just kind of creates a new starting point or like a pretend y-axis. So let's kind of make sure we take some good notes on this first one. This kind of creates a new starting points. Okay. Just know that usually we start at x equals 0, right? We usually always start here. Even if it's a vertical shift, we go up and down, and then we start right along the y-axis at x equals 0, but not with a phase shift. Okay, so again, I'll just read this in case you can't see it. Usually we start at x equals 0, but now with a phase shift. We're going to start at that new phase shift. Okay. All right, so remember, the sine function usually starts at the midline. It always starts at the midline, right? It starts at the midline and goes up. And that's still going to happen here, but I'm going to bump it back on the phase shift to pi over 2. So I'm just going to call this kind of a new pretend y-axis. We usually always start here, but I'm going to draw a little dashed line. I encourage you to do this as well at the negative pi over 2 mark because of the phase shifts. Okay, and then I just start my graph like I always do. So just imagine this y-axis picked up, moved over, and do everything you did the last couple days. Sine starts at the midline. What does it do next? It goes up to the max, unless it's reflected. This is not reflected, but the height is changed to 4. So at my next tick mark, I'm going to go up to a height of 4. Okay, just like that. And everything else continues the same. The next tick mark, sine goes back to midline. Next tick mark, it goes to the minimum, which is going to be a height of 4. Okay. Okay. And then it finishes back to the midline. That was one cycle. I didn't get all the way to 2 pi. That's okay, though. That's everything I need, right, to do one cycle of sine. I'm here, I'm down, and I'm back to where I started. Okay, and then we just extend it the other way. just like we always do. So this one's going to go down to minimum now. If I go backwards, back to midline, back to maximum, next tick mark will be here. Okay, so do you see the big picture? What was different? If it didn't have the plus pi over 2, this would be all moved over this way, that's all. But we just picked up that parent function. Imagine this parent function picked up, kind of shifted over pi over 2, and then it just started here, right? Here, and went up. It did everything the same, just a new starting point. Okay, left or right, depending on the sign. All right. All right, I want you to try this. Example 3 on the next page has a phase shift. I think you can do this after just one, because like I said, just move that pretend y-axis. And I want you to try here for the sine. And then when we're done, we go over feedback. We'll kind of wrap it up with a cosine phase shift, and it has a vertical shift. So we'll see it all come together, okay? Go ahead and pause. Give yourself a couple minutes to try number 3 right here. Okay, so now that we have a phase shift going to the right, what I recommend you do is just to get that new starting point is to shift it over. Get this dashed line going right here at your new starting points. And then just do everything the same you've done before. Okay, so sine starts at the midline. That's my focus. And it's reflected with a height of 4. So my next point needs to be down here. Back to midline, to the max, back to midline. So there's my first cycle I focused on. And then I just tracked it back. Okay. All right, transition to cosine, and it's a vertical shift. You might need a little help on 4, but why don't you take a moment to at least get it going, and then we'll kind of finish it together on 4. Okay, so let's take a look at 4 together and finish it together. Here we go. So we've got the period is still 2 pi over b. So b is 1. Okay, so my tick marks are going to still be pi over 2. We do have a phase shift. Okay, so c over b. So it's just pi. And it's going to go to the left. And then a vertical shift down 2. So I think, just like vertical shifts the last couple of days, I said, right, draw that new midline. I think you should do both. Draw the new phase shift line and draw the new midline. Because what it does is essentially creates like a new origin for you, right? Does that make sense? Because really think about the cosine function, right? If we think about how it starts in relation to the origin, it starts just 1 unit above it at the max. So if we can remember that and find that origin, it starts 1 unit above. And that's it. And then follow the pattern again. Okay, does that make sense? So it had a height of 1. The amplitude was 1. If that was like a 2 or a 3, right, I just have to start a little higher. But we're keeping the amplitude of 1. And then there we go. Okay, so that's why it's called a phase shift to the left, right? Because it's really supposed to start over here. But we picked it up, moved it over, set it down. And just started it like that. Okay. Okay, so let's talk about what you can expect on the quiz. Obviously, some graphs. Finding phase shifts, periods, and stuff like this. Problems like this will definitely be part of the quiz too. I might just give you functions, say, give the phase shift, give the period, give the amplitude. All right. So some of these, and then a mix of graphs of sine, cosine, and all the different transformations that we've been working on, okay? When you get to 56, this actually covers all the different transformations now. This is a good review assignment. It just doesn't include problems, though, like 7 through 10 yesterday and these. So make that a part of your studying, is looking over these problems, okay? But these are just focusing on the graphs. Number 56 has kind of a weird set of directions. The other ones don't. They just say graph 2 full periods. So for 56, do the same thing. Ignore the directions in the book. Just graph it like the others is what this says. Okay, graph it like the others. Okay, let's make sure we're ready for that quiz. We'll wrap up the week that way and have no assignment for the weekend.